So I will discussing about question 16. The problem is to find the maximum product of two distinct numbers in a sequence of non-negative integers. You are required to return the product of these two distinct numbers. For example, in the sequence 5, 6, 2, 7, 4, you are required to return 14, 2, which is 6 multiplied 7. The key require of the algorithm is that, of the problem is that you have to use the brute force approach to find the maximum product, which basically means you have to traverse all the possible pairs of distinct numbers in a sequence. So the answer is to use two layers of for loops. First, you have to have a for loop for I in range n, which is the length of the sequence, and then another a second layer for j range from I plus 1 to n, and then you every time in the loop you take the max between product and the current product and the new product, which is sequence I times sequence j, and then and finally return product, which will be the maximum product of two distinct numbers. The key point is that you for our marking is that you have to show the two layers for loops, which is for I in range n and for j in range I plus 1 to n. And the loop range for j should start from I plus 1 to the length of the sequence. The reason is that the problem requires the two distinct numbers. So if the loop of j starts from 0 to n, it cannot avoid cases such as 7 in the example 7 times 7, which will finally return 49, which is not true since we have to avoid we have to pick two distinct numbers. So j cannot equal to I in the loop, so it have to start from I plus 1. And I will explain further how I mark this problem through several samples. In the sample 1, the error is that the loop range of j is wrong since the j starts from 0 to the length of sequence. So for such kind of errors, the answer will get 4 marks. And sample 2 also has the same problem since it range the loop of j range from I to length of sequence. It should start from I plus 1. So all such kind of errors will get 4 marks for the answer. And another possible way to make sure that only distinct numbers are picked is that you can, in the sample 3, although the loop of j start from 0, it has an additional if condition that says if I equals to j, then this case will be omitted through the condition continue. So this is also okay. So if you have such answers, you will also get 5 marks. And for sample 4, the problem is that some students may read the problem the distinct numbers as two numbers have distinct values. So in this case they will get the if condition that if sequence I do not equal to sequence j, which means the two values instead of two positions. Remember ij here represents the position of the number, whereas sequence I and sequence j is its real value. So if you get such constraints on the pairs of two numbers is also okay. So you will also get 5 marks. And for sample 5 and sample 6, the algorithm seems okay since I think it can really return the right answer. However, the problem that you have to actually implement the two-layer for loops in more detail instead of just speaking in language, in plain language. So such answers will get 3 marks. And for sample 7, there exists 2 layers of for loops, so it will get 2 marks first. However, the problem is that within the for loop, the max equals to I times j. Remember, I and j are the positions instead of the real values. So actually, this sample will not work. It will return if n equals to, for example, 3, it will return 9 because it's just the last 2 positions max positions times time together, which is multiplied together, which is 3 times 3 independent of the values. So this is not correct. So it will get 2 marks due to the 2-layer for loops. And sample 8 is okay. The reason is that here the I is looped in sequence instead of range. In sequence means the I here itself represents the real values. So this answer is much better than the sample 7. The problem of this answer is that it also haven't avoided the 2 same numbers product together, so it will get 4 marks. And yeah, if here has another condition, if condition, to say that I cannot equal to j, then it will get 5 marks. And for sample 9, remember that the key require of the problem is that the question is that you have to implement a brute force algorithm. So if you do not use a brute force algorithm, you will get only 1 marks. For example, sample 9, the idea is to find the largest 2 numbers and multiply them together. The algorithm can return the right answer. However, it's not brute force. So since we think brute force means that you have to traverse the possible all possible pairs of integers. So it will only get 1 marks. And another possible sample 10 is that it uses a sorted sequence. So it first sort the sequence and return the product of the first 2 or last 2 numbers, which is also not brute force, so it will also get 1 mark. And for sample 11, the problem is that it only exists 1 layer of for loops, so it will get only 1 mark. This for loop aims at, so sample 11 will return the maximum between 2 adjacent maximum product between 2 adjacent numbers. So if you show in the if your answer only have 1 layer for loops, however, you somehow show that you want to take the maximum within the for loop, so you will get 1 marks. Whereas for sample 12, it only has 1 layer for loops and it do not tend to take maximum within the for loop, so it will only get 0 marks.